Prove that the function f is given by f of x equal to modulus of x minus 1, where x belongs to R, is not differentiable at x equal to 1 here. Okay. So first they given here f of x is equal to modulus of x minus 1. So this can be written as minus of x minus 1. Modulus, if you remove here, minus of x minus 1 when if x is less than 1. We'll take plus value if x is greater than 1. Okay, less than 1 means minus x, greater than 1 means plus x only we will take here. Okay, so this at x equal to 1 we have to find out here. So first we are finding here left hand derivative here. So which is nothing but limit x tends to a minus f of x minus f of a divided by x minus a here. If you find here limit x tends to a minus, so f of x minus a is nothing but 1 here. So f of 1 divided by x minus 1 we will get here. So which is equal to limit x tends to a minus, so a is nothing but 1 here. So this is limit x tends to 1 minus, okay, limit x tends to 1 minus. So f of x is nothing but minus of x minus 1. Okay, minus f of 1 is nothing but, so 1 if you substitute here, 1 minus 1 will get. Okay, 1 minus 1 divided by x minus 1 only. So which is nothing but, okay, so this 1 minus 1 value is 0 here. So limit x tends to 1 minus minus of x minus 1 divided by x minus 1. This plus 1 minus 1 will get cancelled here. So x minus 1 will get cancelled. Finally, this value will get 1 here. So left hand derivative value is minus 1 here. Now we'll find out right hand derivative. Okay. So RHD is nothing but, so limit x tends to a plus, so f of x minus f of a divided by x minus a. Okay, a value is 1 means limit x tends to 1 plus f of x minus f of 1 divided by x minus 1 here. Okay, limit x tends to 1 plus f of x is nothing but, so 1 plus means we'll take here x minus 1 only, minus f of 1 is nothing but 1 minus 1 divided by x minus 1 here. So plus 1 minus 1 will get cancelled here. Limit x tends to 1 plus, so which is nothing but x minus 1 divided by x minus 1. So x minus 1 will get cancelled. We'll get here this value is 1 here. Or HD is 1. So but here LHD is minus 1, or HD is plus 1 here. So left hand derivative which is not equal to right hand derivative. So therefore f is not differentiable at x is equal to 1 here. Okay. Next 10th one. Prove that greatest integer function defined by f of x is equal to greatest integer function x, which is nothing but 0 less than x less than 3, is not differentiable at x equal to 1, x equal to 2 here. So first we have to know about what is mean by greatest integer function here. Okay, so greatest integer value is nothing but which is not less than or equal to x here. Okay, for example here, greatest integer function of 2 is nothing but 2 only. Greatest integer function of 2.1 also 2 only. Okay, greatest integer function 2.1, 2.2, 2.3 up to 2.9 also. This is values of 2 only. Next, greatest integer function of 3 is nothing but 3 here, which means 3.0. Next, 3.1 also 3 only. So greatest integer function of 3.4 also 3 only. So like this, all the greatest integer function, which is nothing but less than or equal to that integer values here. Okay. So at x equal to 1, we are taking here. Let f of x is equal to greatest integer function we are taking here. So first we are finding here left hand derivative here. So which is nothing but limit h tends to 0 minus f of a minus h minus f of a divided by minus h. So 0 minus means minus h will take here. So limit h tends to 0 minus f of a minus h. So first we are taking here at x equal to 1 here. At x equal to 1. So 0 minus means 1 we are taking means. So a minus 1. So f of a minus h is nothing but if we are taking this one a minus h means 1 minus h it will become here. So 1 minus h minus greatest integer function of 1 divided by minus h here. So why? Because a minus h is nothing but a minus 1 we will get here. Okay. So limit h tends to 0 minus. So if you substitute here at 1 value, this is 1 minus 1 divided by minus h you will get here. So greatest integer function of 1 is nothing but 1 only here. So 1 will get cancelled here. So this value is nothing but limit h tends to 0 minus minus 1 divided by minus h here. So minus will get cancelled. So limit h tends to 0 minus 1 by h. So now if you substitute in place of h is 0, 1 by 0 will get here. 1 by 0 is not defined. So that value is infinity here. Okay. This is the LHD value. Next, RHD if you find out here. So RHD is limit h tends to 0 plus we will take. So f of a plus h minus f of a divided by h here. So limit h tends to 0 plus f of a plus h is nothing but f of 1 plus h minus f of a is nothing but f of 1 divided by h here. So limit h tends to 0 plus. So f of 1 plus h is nothing but 1 plus h only. Okay. Minus f of 1 is nothing but greatest integer function 1 we will get here divided by h here. So greatest integer function of 1 plus h is nothing but 1 only. Okay. So greatest integer function of a plus h is nothing but a only will get here. Okay. So limit h tends to 0 plus. So greatest integer function of 1 plus h is 1 only minus greatest integer function of 1 also 1 only divided by h you will get here. So 1 minus 1 is 0. So limit h tends to 0 plus 0 by h. So 0 by anything is nothing but we'll get here 0 here. So RHD is equal to 0 we are getting here. So but here therefore LHD is not equal to RHD. So therefore f is not differentiable at x equal to 1 here. Okay. Next we have to check for x equal to 2. At x equal to 2 here. Same will follow here. So left hand derivative is limit h tends to 0 minus f of a minus h minus f of a divided by minus h here. So this is equal to limit h tends to 0 minus f of a minus h is 2 minus h minus f of 2 divided by minus h here. So limit h tends to 0 minus. So f of 2 minus h is nothing but greatest integer function of 2 minus h minus f of 2 is nothing but greatest integer function of 2 divided by minus h here. So limit h tends to 0 minus. Greatest integer function of 2 minus h is 2 minus 1. Okay. So 2 minus 1 we will get here. And this is minus 2 divided by minus h you will get here. Okay. So limit h tends to 0 minus 2 minus 1 is 1. 1 minus 2 is minus 1 divided by minus h. So minus minus get cancelled. 1 by h is nothing but h if you substitute 0. 1 by 0 is nothing but infinity will get here. Next, RHD value we are finding here. So RHD also limit, sorry, h tends to 0 plus f of a plus h minus f of a divided by h here. Okay. So limit h tends to 0 plus f of 2 plus h minus f of 2 divided by h here. Limit h tends to 0 plus f of 2 plus h is nothing but greatest integer function of 2 plus h minus f of 2 also greatest integer function of 2 divided by h. So limit h tends to 0 plus. So 2 plus h value is nothing but 2 plus 1 only minus 2 divided by h here. 2 plus 1 is 3. 3 minus 2. Okay. So here, if you substitute here, h value is 0. So this will become here. It's not 1 more. It is 0 only will get here. Okay. So which means 2. Therefore, limit h tends to 0 plus 2 minus 2 is 0. 0 by h is nothing but 0 here. So therefore, LHD which is not equal to RHD. Therefore, F is not differentiable at x is equal to 2 here. Okay.